Because in reality, this is one of the most sensitive, high-risk transitions in the entire yacht building process. One wrong assumption here can delay the build by months, quietly inflate costs, and even compromise structural quality before the yacht ever hits the water. And if you skip understanding how this move actually works behind the scenes, you don't just lose time. You lose control over the entire project timeline. But if you follow how experienced shipyards and production teams handle a transition like this, you gain a serious advantage: cleaner coordination, faster progress, fewer surprises, and a much safer build process from start to finish. In this breakdown, I'm walking you through exactly how a move like the NautiStyles Yacht build being transferred to a new shipyard actually unfolds, step by step, in the correct order, no fluff. Just the real process professionals follow when everything has to go right by Has 1. Understanding why the move is happening, identify the real reason behind the relocation first. You need to understand why the yacht build is being moved at all. This matters because the reason dictates everything: timing, risk level, and how carefully the transition must be handled. If you skip this, you'll assume it's just operational convenience, when in reality it could be capacity limits, technical requirements, or scheduling pressure. Pro tip: experienced project managers always ask what changed internally, not just where is it going next. Map the current build stage next. You assess exactly where the yacht is in its construction life cycle: hull completion, interior fit-out, systems integration. Each stage changes how delicate the move is. If you misjudge this, you could move a partially sensitive structure at the wrong time, risking damage or rework. Insider detail: late-stage electrical and hydraulic systems are often the biggest relocation risk, not the hull itself. To fast 2. Pre-move inspection and stabilization. Conduct a full structural audit now. The yacht is inspected from top to bottom before any movement begins. This ensures there are no weak points that could be stressed during transport. If skipped, microfractures or unfinished joints can worsen during lifting or towing. Pro tip: shipyards often use laser alignment checks at this stage to lock in structural integrity baselines. Secure all onboard systems. Every loose system, piping, wiring, temporary fittings is secured or temporarily removed. This prevents vibration damage during the move. If ignored, internal systems can shift, snap, or disconnect mid-transfer, leading to expensive delays. Insider detail: even APE systems are often still fragile because they haven't been fully sealed yet. Bower and timing analysis before anything moves. Conditions are reviewed carefully. Wind, tide, and transport route stability all matter here. If rushed, even a short-distance relocation can become risky. Pro tip: most professional shipyard moves are scheduled during low-wind, low-tide windows, not just convenient calendar dates. DAF 3. Transport engineering and preparation select the relocation method. Now the team decides how the yacht will actually be moved: float on, float off, heavy lift transport, or tow transfer. This is critical because each method changes stress points on the vessel. If chosen incorrectly, the hull can be unevenly loaded during transit. Pro tip: larger yachts often use modular transport systems to reduce pressure concentration on the keel. Reinforce critical load points. Special supports are installed under the hull and key structural zones. These distribute weight evenly during lifting or floating transfer. If skipped, pressure imbalance can cause warping or alignment issues later. Insider detail: engineers often simulate load distribution digitally before placing a single support block. Create a step-by-step move sequence. A detailed operational plan is built, outlining every minute of the move. This includes lift timing, tug coordination, and docking alignment. If this is rushed or unclear, Coordination errors can lead to dangerous misalignment. Pro tip: the best shipyards run a full dry simulation before actual movement day BOF 4. Execution of the move initiate controlled lift or float transfer. The yacht is carefully lifted or floated depending on the method chosen. This is one of the highest risk moments in the entire process. If anything shifts unexpectedly, structural stress can spike instantly. Pro tip: engineers monitor hull flex in real time using sensor arrays during this step. Maintain constant communication between teams. Every tug, crane operator, and dock controller stays in sync. If communication breaks down, timing mismatches can create dangerous tension on the vessel. Insider detail: even a few seconds of delay between commands can misalign. Docking angles. X slow transfer to new shipyard. The yacht is moved gradually along a controlled route. Speed is intentionally kept low to avoid wave or current impact. If rushed, water resistance can create uneven drag forces on the hull. Pro tip: experienced captains often prioritize stability over speed, even if the distance is short. Bond 5. Arrival and reestablishment at new shipyard. Precision docking into new facility. The yacht is aligned into its new position with millimeter-level accuracy. This ensures all future build phases continue without structural offset issues. If misaligned, later installations like interior cabinetry or systems integration can fail to fit correctly. Insider detail: laser docking guides are often used for final positioning. Room transport supports safely. All temporary supports and stabilization systems are removed in sequence. This must be done gradually to avoid sudden load shifts. If rushed, internal stress redistribution can damage newly finished sections. Pro tip: removal is usually done in reverse order of installation to maintain balance. Revalidation of structural integrity. A full post-move inspection is conducted. This confirms nothing shifted, cracked, or misaligned during transport. If skipped, hidden issues can surface later during sea trials. Insider detail: this is often treated like a second construction audit, not just a checkup. C6. Resuming construction with optimization. Recalibrate all systems and measurements. All onboard systems are rechecked and realigned after movement. This ensures nothing drifted during transport stress. If ignored, small misalignments can compound into major integration problems later. Pro tip: this is where most shipyards quietly recover lost precision. Update build timeline and workflow. The project schedule is adjusted based on the move outcome. Delays or gains are absorbed into the new production plan. If not updated properly, teams work off outdated assumptions, causing inefficiency. Insider detail: experienced project managers always rebuild the schedule immediately after relocation, not days later. Dumb interior and systems installation. Once stability is confirmed, full construction continues. This is where the yacht starts regaining momentum after disruption. If rushed before verification, rework becomes almost inevitable. Pro tip: the smoothest projects restart in phases, not all at once. Traps to avoid during yacht relocation. The biggest mistake is assuming the move is just a transportation event. It's not. It's a structural transition phase. Another trap is underestimating timing sensitivity. Even a short delay in weather windows can cascade into weeks of scheduling disruption. And finally, skipping post-move inspection is one of the most expensive shortcuts in yacht construction. Problems caught early are minor. Problems found later are structural. Most people never see this part of yacht building. They only see the polished final result. But what happens during moments like this relocation is exactly what determines whether the final yacht is flawless or full of hidden compromises. If you've ever followed a yacht build before, have you ever thought about how much happens between shipyards that most viewers never see?